Right, hi. So what we're going to do to this element? Okay, so we want to find from here, we want to find the principal stresses, the maximum shearing stress, and I also would like to do a bit more is the orientation of the principal plane. And also we can construct 3D mold circle. Okay. So I'm going to do a bit more on this rather than just find principal stress. Okay, now, so if we base on our orientation, we know that this is X, and this is Y, and this is Z. So we will label this face as our Y face. This is our Z, okay, and this is our X. So let's focus on 2D first, okay? Let's look at 2D. Element. So we're going to sketch out a 2D element viewing in the YZ orientation. Okay, so this is our YZ orientation. So when you draw that, so we have the shear going at 18.535 times 10^6 Pascal. And then we have a compression coming in at 14.948 times 10^6 Pascal. So now we're going to construct a mold circle. So we have our axis over here. Okay, so this will be our this in compression. So I'm going to focus on compression. So we get about 14. So I'm going to call this 0. So we're going to have 5 minus 10 minus 15 minus 20. So you're going to have 5, 10. I'm going to extend to 15. So this is normal stress. Let me go to 25 and 30 since we have space. Then in terms of shear, shear stress, element rotation clockwise, element rotation anti-clockwise, 5, 10, 15, 20. And then the other side is minus 5, 10, 15, and minus 20. Okay. So we are aware that one of the stress state is stress in the Z direction. So we're going to label this our Z, and this is our Y. So over here, this is your stress Y line, okay, and your stress Z is minus 14 which is close to minus 15. So this is your stress Z line. And then we have a shear of 18 or 18.5. So 18.5, I'm just going to eyeball this 17, 18, 17.5. Okay, so I'll take it somewhere around there. Okay, so again, somewhere around here. So if you look at Z now, point Z, right, it's on the stress Z line, okay, which is on this line over here. And if you fix on the center, this shear force over here will generate a clockwise rotation, right? A clockwise rotation. So this means that point Z is on the top. It cannot be at the bottom because the element rotation is in the anti-clockwise direction. And then if you look at Y, okay, look at Y now, right? So you fix at the center. This arrow over here will generate an element rotation based on the center anti-clockwise direction. So this is your point Y. Okay, so you construct a straight line. So very easily we can calculate the center of the circle. Which is our stress average. So it's equal to minus 14.948 plus by 0 because of the normal, the stress in stress Y is 0, divided by 2. So 14.948 divided by 2 minus 7.474 times 10 to the power 6 Pascal. Okay, so we have calculated at this point, right, the location of this line. So 7.47 is about 7.5, slightly towards the left. So we discovered that this is our stress average. Okay, so the distance from here to here this is our stress average. Then we can calculate the radius of the circle. For this case, this is our tau max. So shear stress. No. So this will be equal to 7.474 squared plus by the shear, right, it's 18.535 squared. Okay, so we have taken the 7 distance and the height. Okay, so tau max, so where we're calculating now is this is the distance that we are trying to determine now. So it's this distance from here to here. So this is the radius of the circle. Right, so this is the tau max that you see. So this is 7.474 squared plus by 18.5 squared square root is 19.98. Right, so this is 19.98. 5 times 10 to the power 6 Pascal. Okay, I'll do it again. 7.474 18.535 squared Okay, 19.985. So you can find your principal stress, stress 1 and 2. So it's equal to minus 7.474 plus or minus 19.985. Okay, so your both of maximum stress is positive 12.515 times by 10 power 6 Pascal, and the other value is minus 27.459 times 10 to the power 6 Pascal. Okay, so we have found. So the limits, so we have minus over here, so we know that the maximum is 20. One side is 12.5, the other side is 27.5. Let me stretch this a bit. It's about right. Okay, so that's our mole circle. So I'm going to go further. Let's find our principal plane. So over here, this is our 2 theta p. You can find from z point or from x point, either way is fine. So we know that tangent 2 theta p is equal to the y-axis or the y value, which is 18.535 divided by 7.474. So therefore we get 2 theta p, so 18.535 divided by 7.474 inverse tangent, so it's about 68 degrees. And it's going to rotate anti-clockwise, like what it says down here. Okay, both are anti-clockwise. Towards over here is your stress 1, and over here is your stress 2. Okay, there's the location of your principal plane. So let me do it again. 18.535 divided by 7. Inverse tangent, 68 degrees. Okay, and from here we can also draw. Okay, we can also draw the element where the principal of the element oriented based on its principal plane, where shear stress is equal to 0. Okay, so we can now have, so now it's 68, and theta p is equal to 68 divided by 2, and this is 34 degrees when the anti-clockwise direction. Okay, so this theta p, so 2 theta p is on mole circle. Theta p is for the element. And why is that? Okay, so if you look at point y to point z, the orientation is what? 90 degrees. Over here, y to z is 180 degrees. So if on mole circle is 180 degrees, on the element you have to divide by 2. That's why 34 degrees anti-clockwise. So we're going to draw this at 34 degrees. How does the element look like? Okay, so we have our zero line. So this is our 0. I'm going to draw an orange. This is our 0 line. And this is our 0 line also. And then anti-clockwise 34 degrees. I'm trying to get 34 degrees. So this is about 34 degrees. Alright. So this is the orientation of the principal plane now. So we're going to draw our element oriented based on the principal plane. Okay, so this is right. Then you will label this line over here. And you label this line over here. So these two lines that I've just drawn, this is your line representing point Y, and this is your line representing point Z. So Y rotated anti-clockwise, right? Rotated anti-clockwise in this way by 34 degrees. On most circle, Y represent rotating by 68 degrees. It's stress 1. So stress 1 value is positive, so you're going to have a tensile. And if we have calculated this value, will be 12.515 megapascal. And the other point from Z, okay, from Z again, rotate by anti-clockwise by 68 degrees, which is 34, is going to be having a compression. Alright, compression of 27.459. Okay, so 27.459 megapascal. Okay, so this is how your element look like on the principal plane. So the next thing that I want to show you, okay, so we've done it. We're going to draw 3D mold circle based on this element over here. And we know that element, or at point X, everything is equal to 0. So this in fact is your point X over here. Everything is equal to 0. Okay. So we can construct 3 mold circle now. Okay. So one of the mold circle, it will be look like this. So, but the first thing of all, because this represents YZ, okay, you can see Y and Z touching on the circle. This mold circle, the first mold circle is YZ plane. And then the next one that we're going to draw over here, right? So 2 or 5. So I'm just going to eyeball this roughly. I'm going to use a different color. Next small circle you see over here, right? And this is for X, you can see, and the closest point, which is your Y over here. So this circle represents the most circle in your XY plane, right? So it's the acute angle, the smaller than 90 degrees. So X is here, the distance traveled to Y over here, from here to here is closer than Z. That's why you call it XY plane. And the last one, the last circle, okay, as I said, I'm just eyeballing this. Oh, does not look well. Okay, 2, 4, 5.5. So the last circle, right? This is the last circle over here. So this circle, right? So again, it has the Z point and closer to Y. So this will be in your X Z plane. Okay. And your YZ plane, so YZ plane is this plane. Okay, YZ plane is this plane. So because the surface area is larger, We call this our in plane. Okay, so our YZ plane is our in plane, and the other two is out of plane. And this is out of plane also. Okay, so I hope this will let you understand better on 2D mole circle and 3D mole circle. Thank you.